Well, we've talked about the atmosphere and the other spheres that encompass the Earth and create the system that we live in today. And so the notes that we're taking today are in the form of a table. So what we're going to do is every slide is going to discuss some of the attributes of each sphere. And we're going to work from left to right to fill in each block. And I'll explain a little bit about the importance of the information you're writing down as we go from Earth out towards outer space and enter into each sphere. So starting with the troposphere, I know that in science class we typically will use the metric system to talk about different measurements like length and mass, and we're still using that today, but I wanted to also include this picture that helps us understand what it means when we say a certain amount of kilometers, because I know it's hard for me to remember sometimes too. So starting with the troposphere, that is the sphere that we live in, that we are interacting with one-on-one, and this extends up to 12 kilometers on average above Earth, and that is the same thing as saying 7.5 miles. So hopefully that can help you understand a little bit better how high off the ground this is extending out into the atmosphere. So for the troposphere, the altitude range is the first block that you're filling in on your paper, and it's interesting because the troposphere is different heights based on where you are on Earth. So your latitude is the distance from the equator that you're located on the Earth, and so near the poles, the tops and bottom of the Earth, the troposphere goes from 0 kilometers, so the ground, to about 8 kilometers above the ground. So that's the altitude, so the height from the ground. But near the equator, it's a little thicker because of the way the Earth spins, and we'll get into more information about why that is in future lessons. But the equator can have troposphere extend up to 18 kilometers, and so it's a little thicker there. That means that the Earth involving the atmosphere is actually a little bit more spread out or fatter in the middle where the equator is versus at the poles. The height of the troposphere also varies with the seasons. So depending on what season you're experiencing, the troposphere might be different heights. The next column says that altitude increases the pressure, and you're filling in the blank. The pressure decreases as you go higher into the air in the troposphere. So that means the pressure that you feel from all of the air sitting on top of you gets less and less the further up you go. And the reason is because there's less air sitting over you. Kind of makes sense if you think about going underwater in a pool. The farther you go underwater, the more pressure you feel. Sometimes your ears start to pop because there's so much pressure, and so it's the same concept as we deal with the air in the atmosphere. As we increase in altitude, so again, as we go up from the ground, the temperature will decrease. And if you've ever hiked a mountain, I love hiking, so I go to Sharp Top with some friends every once in a while. And as you go higher on the mountain, usually it gets about 10 degrees cooler. And so the temperature decreases at a rate of about 6.5 degrees Celsius for every kilometer that you travel up into the atmosphere above Earth, up until it reaches about negative 60 degrees Celsius. Another important characteristic that we need to include in that last block for the troposphere is that all of the weather that we experience on Earth happens within just this region. So once you get out of this region, you're entering different parts of the atmosphere where you're above where all of the turbulence would be. So if you've ever flown in a plane before, a lot of times planes will fly just above this to avoid the turbulence that happens within the troposphere. So the next step up from the troposphere, if we're flying into outer space, the next sphere you'd go through is called the stratosphere. This one extends up to about 50 kilometers above the Earth, and that is the same thing as saying 21.1 miles. So a little further than the distance between Amherst and Lynchburg. So again, based on how high the troposphere goes, on average, the stratosphere starts at about 12 kilometers and it'll go to 50 kilometers. And the next column over is the altitude increases. So as you continue to go up and up and up towards space, the pressure continues to decrease because you still have less and less and less air sitting on top of you. The interesting thing is that this time, as you enter into this new sphere, part of the atmosphere, the temperature begins to increase as you continue to go up. So before the troposphere, it was decreasing and decreasing up until you get to the place between the troposphere and the stratosphere. And then the temperature starts to change, it starts to increase. And it could range from negative 60 degrees, where it meets the troposphere. It could raise all the way up to about 0 degrees Celsius, which hopefully you remember that's the freezing point of water. An important characteristic is that the ozone layer is located here because there's so much concentration of ozone. And ozone is a compound of oxygen that's a little different from the oxygen we breathe. Oxygen we breathe is made up of two atoms of oxygen that are fused together in a molecule called O2. You've heard that before. Ozone is actually made up of three molecules or three atoms of oxygen to make a molecule called O3. And so its job is to absorb UV radiation, and it helps to protect us from the harmful rays that would cause cancer. And so because it's absorbing all of this radiation within that sphere itself, it causes an increase in temperature as you continue to go up. So next, once you get to the top of the stratosphere, you hit something called the mesosphere. And the mesosphere will go up to 80 kilometers above Earth. And so that's the same thing as almost 50 miles. So once you travel 50 miles, maybe if you're driving a car, it would take you almost an hour to get to the top of the mesosphere if you were just driving a regular speed limit. So what you'll write down in your first column there is that the altitude ranges from 50 to 80 kilometers. And as you continue to go up and up and up, as if you're traveling to space in a shuttle, the pressure that would be on your vehicle would continue to decrease more and more because there's less and less air sitting on top of you, putting pressure on you. As the altitude increases, the temperature suddenly takes a turn and starts to decrease again because the stratosphere is made up of a lot of ozone, and that ozone was, again, absorbing a lot of the UV rays from the solar radiation, and so that UV ray was kind of transferring into heat within that sphere. And so because the ozone does not exist in the mesosphere, the temperature ranges from 0 degrees, like it was in the stratosphere, all the way to nearly, this says 90 degrees Celsius, and I just realized that is totally a typo, and I didn't realize it till it's being published. So this is supposed to say negative 90 degrees Celsius. Did you know teachers can make mistakes too? So this is actually going to be the coldest temperature that we would experience in the atmosphere. This one is kind of hard to get information about it because weather balloons don't make it up as far as the mesosphere to be able to take readings of the temperature. But satellites can't orbit so far down into our atmosphere that it would get to the mesosphere. So it's kind of a mysterious level of the atmosphere versus the other ones that we've been able to take some readings of. But one important characteristic that we can write down in our notes is that most meteors, once they enter our atmosphere, they'll burn up in this layer before they reach us. So that's pretty cool. And now that we've gone through the troposphere and the stratosphere and the mesosphere, we would reach the thermosphere if we were continuing out from Earth to space. And if we continued going and going and going, it's kind of hard to tell where the actual boundary would be because it gradually turns into what we would consider to be outer space because the atoms are so far apart. But generally, people consider it to be about 320 kilometers in height above the Earth, which is about the same thing as 195 miles. That's a really, really long distance. So we've got a little more information to write down, and I'll make sure that you understand what to do because some of this you don't necessarily have to write. I just wanted to include it in our discussion. First of all, the ionosphere and exosphere are two components of the thermosphere, so they're not specific to themselves necessarily. But from the 80 kilometer mark to 400 kilometers is considered the ionosphere. And then from 400 kilometers on out into space, that's called the exosphere. And if you know the prefix exo, you've probably heard it in life science with exoskeleton, and you've heard exothermic reactions in physical science, and we've learned that exo means release or the outside. And so hopefully it kind of makes sense to you as to why this is called the exosphere. Again, following the same pattern as the altitude continues to increase, so as you continue to get further and further away from Earth and closer to outer space, the pressure continues to decrease because there's less air sitting on top of you. As the altitude increases, the temperature again takes another turn. If we were to look at that temperature graph that we've seen in class, the temperature starts to increase again, so you have a positive slope on the graph. And it can range from negative 90 degrees Celsius to as high as 1,000 degrees Celsius, as far as scientists know. There are special instruments that are needed to be able to record those temperatures, because up that high, the particles that make up the air are so far apart that to use a regular thermometer, they don't hit it often enough to get an accurate reading of how much energy they have. And so they've had to create some special technology to find that out. The increase actually happens because nitrogen and oxygen atoms absorb solar radiation. And what's interesting is that down in the troposphere, these guys exist in pairs. They exist in twos. So you usually see a nitrogen atom with another nitrogen atom kind of hooked together. The same way with oxygen. The kind of oxygen we breathe, like I said earlier, is O2. But up there in the thermosphere, they've been kind of ripped away from each other and created ions. So in the important characteristic column, auroras are formed in the ionosphere from these ions interacting with the solar radiation. So hopefully we can take a look at a picture or a video of this in class sometime soon. An aurora is the same thing. It's just another word for the northern or the southern lights. So if any of you have ever had the amazing experience of seeing this firsthand, I'd love to hear about it. I have never seen it. I have some family that has traveled to Alaska, so they've seen it with their own eyes, and they've told me how amazing it is. And so someday that's my goal, but I haven't made it there yet. Finally, the last characteristic we want to write down is that the exosphere is the layer that extends into outer space. And again, exo means the outside or exit. So hopefully as you put those two words together in your mind, it makes sense as to why they call it that. If you have any questions, I suggest you write them down underneath the chart that you filled out or above, and make sure that you address them in class. I'd hate for you to be curious about something or to be confused or wonder and then not ask and try to figure out the answer. So please make sure you're communicating that, and I will see you when we're together again.